Okay, on to example 3. This is about comparing and ordering radicals. In this example, 5 bent wood boxes, each in the shape of a cube, have the following diagonal lengths in centimeters. 4 times 13 to the power of a half, 8 root 3, 14 root 202, and 10 root 2. Order the diagonal lengths from least to greatest without using a calculator. Well, the easiest way to probably do this without a calculator is to expand them all and make them all entire radicals. So let's start with that. First of all, 4 to the power of 13 to a half. 13 to the power of a half is the same as the square root of 13. So 4 root 13, we're going to square the 4, put it under the root sign. So we're going to get root 16 times root 13, and that's going to equal root 208. 8 root 3, well, we're going to square the 8, make that root 64 times root 3. That's root 192. 14, square it, put under the root sign, root 196. Root 202 is given. And our last one, 10 root 2, is root 100 times root 2, which is root 200. Now you can see from smallest to largest, we're going to start with 8 root 3, 14, 10 root 2, root 202, and 4 root 13 to 1/2. In example 4, now we're going to look at adding and subtracting these radicals. We can simplify radicals by combining the like terms. However, sometimes we have to reduce them first before we can add them. Root 50, well, we're going to look for a perfect square that can divide into root 50, and the biggest one is root 25. So we'll rewrite this as root 25 times root 2 plus 3 root 2. The root 25 will simplify to be 5. 5 root 2 plus 3 root 2 will give us 8 root 2. And the next one, negative root 27, is like negative 1 times root 9 times root 3. Root 9 will simplify to be 3. So this will be negative 3 root 3. The next one stays the same, negative plus 3 root 5. Root 80, well, the biggest perfect square that I can divide into 80 is going to be 16. So root 16 times root 5 will be minus 4 root 5. Lastly, minus 2 root 12. Well, the root 12 can break into root 4 root 3. That'll be negative 2 times another 2 times root 3. The negative 2 times 2 will become negative 4 root 3. Now I've looked at this, it's simplified. Now I can gather together the like terms. Negative 3 root 3 minus 4 root 3 is negative 7 root 3. The last part, back this up, is 3 root 5 minus 4 root 5 is negative 1 root 5. The last example, root 4c minus 4 root 9c. Well, can't do anything about the variable, but I can split root 4c into root 4 times root c, which will be 2 root c. The next one is minus 4 times root 9 times root c. And again, 9 can be broken into 3. So it's negative 4 times 3, or negative 12 root c, and that'll become negative 10 root c.